So as you can see, there's a huge machine right beside us. I am gonna hook myself to it and swing. That's like what, 12 feet? How's that? Today, we're talking about our solar panels. Stall! Oh. Just a heads up, there's gonna be a lot of bird chatter throughout this video. They're very talkative today, and our hair is wild because it's humid. So this is our third and final installment of our electrical sprinter build series, and the first one we covered the AC and DC connections within our van, and then the second one we went through and covered all of the components including batteries and the way we charge that and run our whole system. And now we're going to focus on the solar, specifically our panels and the way we've configured them.
So if you haven't checked out those two previous electrical videos, you should do that.
So before we get into our solar setup, maybe we could talk a little bit about what solar is or how it works.
Maybe.
You have to say yeah, and then you lead into this.
Do it. On a very basic level, sunlight is composed of photons, or particles of solar energy. And solar panels work by absorbing those photons in order to harness their energy and create electricity. How does that work?
Solar panels contain energy harvesting technology called photovoltaic cells, or PV cells. As solar energy or photons are absorbed into a PV cell, they cause electrons to dislodge and come loose within the PV cell, basically creating an electron disco party. Those crazy electrons then migrate to the surface of the PV cell, creating a negative flow and voltage potential. When the solar panel is connected in an electrical circuit to an external load, such as the batteries in our van, the electrons that migrate to the surface of the cells then flow into the circuit, creating DC or direct current electricity to the battery. But that doesn't mean they're wired directly into our batteries. They first have to make a pit stop at a charge controller, but we're gonna talk about that later on.
Now, the efficiency of a solar panel is determined by numerous internal and external variables, including climate, temperature, how many and how big the PV cells are, as well as surrounding components in your solar setup. For example, the number of bus bars on each panel and the width of each bus bar can add to or decrease the efficiency of the panel. A bus bar is a thin metal strip or wire that conducts electricity between each PV cell. You can see the bus bars on your panel as the vertical lines that run parallel to the panel's edges. Bus bars are commonly made of a metallic material like aluminum, copper, tin, or nickel. Because bus bars conduct and distribute electricity from the PV cells, under perfect conditions, the more bus bars, the higher the panel efficiency and the more energy it can produce. Now, many solar panels on the market are 5BB, meaning there are 5 bus bars per module. But BougeRV reached out to us with their new 9BB solar panel, which, as the name implies, has 9 bus bars per module. Because the number of bus bars reduces the distance between each bus bar, the electrical current length is also shorter, theoretically translating to better overall efficiency of each panel.
BougeRV was willing to provide 2 of the 3 panels that we needed for our system, so we decided to give them a try. We went with the 9BB 200 watt 12 volt panels, which according to BougeRV achieve up to 22.5% conversion rate compared to typical 5BB panels with a max of 18% conversion. Their panels also feature a thinner bus bar design, which reduces the total covered area on the panel, allowing for more sunlight to be absorbed by the PV cells. Having a higher number of bus bars also decreases the impact of microfractures within the panel, so it gives it a longer lifespan. These panels are also an average of 8% smaller than other 200 watt panels on the market, making them more compact with the same amount of power. The panels also feature aluminum framing, which is anti-corrosive, with dimensions of 54.72 inches by 27.8 inches by 1.38 inches and weigh 22.93 pounds, or 10.4 kilograms. And their resilient design makes them able to withstand high winds and heavy snow loads, making them suitable for harsh outdoor environments, much like the conditions we encounter while adventuring in the van.
So now that you know how panels work and why we went with the specific model we did, let's talk about how to choose the correct wattage for your panel configuration. First, you'll want to identify all the items in your van that you're going to need to power. Next, you'll need to list out the power draw from each of those items, both DC and AC appliances, to figure out your daily power requirements. Explorers.life makes a nice Excel sheet template that can help you organize all of your items and identify the power required for each. Ultimately, you want to calculate how many amp hours you'll require on a daily basis.
This will inform what size battery bank you'll need to power all the items within your system, and generally speaking, the solar wattage should be about double the amp hours of your battery bank. But this isn't a necessity, it's more of a recommendation. It's fine to size down, just be aware of how much power you're using on a daily basis.
So for our system, because we have 400 amp hours of batteries, ideally we would have about 800 watts of solar energy. But because up on our roof, we wanted to make space for a cargo box, our max air fan, our air cooler from Fresair, as well as a fly fishing rod vault. We didn't have enough room for 4 panels, so we ended up mounting 3 panels, which is a total of 600 watts. Break.
So now that you've figured out what panels to go with, let's start to talk about how you're gonna mount them to your van. In my previous van, I just used some like proprietary ProMaster mounting hardware along with a product called Super Strut, and you can find that at something like Home Depot. But if you fast forward to present day, there's tons of products out there made by various companies that are specific to mounting solar panels in roof racks that are capable of mounting solar panels pretty easily. But since our van came with a utility rack already on top of it, we decided to modify it to fit our panels along with all the other garbage we plan on putting up there.
Ben started by hauling all of our roof items, which included 3 solar panels, a cargo carrier, and our fly fishing rod vault, up to the top of the van to figure out the best layout with our max air fan and our Fresair unit.
So there's a lot of pre-planning involved.
After a few configurations, it was obvious that we were going to have to hack the utility rack apart and cut out pretty much everything except the outer perimeter, which turned out to be a serious pain in the butt.
The roof rack weighed a ton, and we didn't really have a safe way to get it off the top of our van to the ground, so we had to improvise. We ended up removing the roof rack, placing it on Julie's roof, and using a grinder to remove the center walkway, reducing the weight so we could get that hunk of metal off the roof safely. What's Julie's opinion about heights?
I'm scared.
We then broke it down even more to its bare bones, sanded it, and recoated it with a fresh layer of bed liner. But we're not done yet. We laid all of our panels back on the rack along with our carrier box to identify where we'd need mounting points. We ended up using 6 pieces of aluminum extrusion to Frankenstein cross beams on the roof rack that we attached to the rack using rib nuts and L brackets. With all the cross supports in place, we were able to attach the 3 panels using additional L brackets and M6 bolts. We mounted these with a combination of bolts, stop nuts, and lock washers, and just regular washers. So it has 2 points of contact with this L bracket, and we have 4 mounting points for this front one, and then we have 5 for the back two. Okay.
Now I'll mention that BougeRV panels do come pre-drilled to make installation easier, but since we like to make things unnecessarily difficult, we decided to drill our own holes in locations that we thought would work better for our setup.
And of course, it didn't quite work out. See that broken spot there? We drilled a hole too close to where these 2 brackets, these side pieces meet, and it broke. It snapped it. So we had to fashion up a little fix, you know, for now, which is some metal wire. But we're gonna have to now reinforce probably this whole piece so that we can have a solid mounting point. So, you know, don't do that. Maybe use the holes that are already there. All in all, there's several ways to mount the panels to your van, and there's not necessarily one right way, but there are plenty of wrong ways. So just make sure when you get them up there, they're nice and secure, because when you're driving down the road, say on a highway through Kansas, and there's a tornado whipping through, it's gonna have a lot of force working against them, and you don't want them blowing off while you're moving at 80 miles per hour. But once you know how you're gonna be mounting those panels to your van, you can start wiring them up.
Just like wiring your batteries, you have two options on how to wire your panels together if you're needing more than one in your setup. You can either wire them in parallel or in series. To wire your panels in parallel, connect all the positive terminals on each panel together, and then connect all of the negative terminals from each panel together. In this method, the resulting current will equal the sum of all the panel's amperages. However, the total voltage will be equal to the output voltage of just one single panel.
When wiring in series, you connect the positive terminal of one panel to the negative terminal of the next, and so on and so forth for as many panels as you have. In this method, the resulting voltage will be the sum of all the panel voltages in the series, and the current will be equal to the output current of a single panel.
So which option is better? Well, like everything else in this series, the answer is it depends. But here are a few things to consider when you're making your decision. Solar panels in a parallel system operate independently of one another, and therefore are a good option for mixed light conditions. So if shade covers one or two of your panels, the remaining panels will continue to generate power as normal. Additionally, for a low voltage system, you can use a lower cost PWM charge controller, which is a bit more of a budget-friendly option. Although we will note that additional components are required in this style, such as a combiner box, which can be bulky and a little bit expensive. You should also expect to use higher gauge wire depending on the distance to your charge controller, in addition to more breakers and more wire connectors.
Now, wiring your panels in series is ideal for full sun, unshaded conditions since your panels function together and not independently. So if one panel is shaded, the entire system's power output will be impaired. If you need a low amperage system though, wiring in series would be more ideal since the amperage remains the same as one panel. I will say in a series system, you'll need to use an MPPT controller to accept a higher voltage input and still be able to charge your 12-volt batteries, which tend to be a bit more costly than the PWM controllers in a parallel system.
So we'll end your torturous suspense by saying we wired our panels in series. Ultimately, we decided that it'd be more efficient to receive the higher voltage from wiring our panels in series and use the power of the MPPT controller so our solar panels can operate at a lower capacity to charge our batteries. It means our panels will start charging earlier in the day and stay charging later in the evening when the sun angles are lower, since our MPPT controller can handle a bigger range of voltage input, especially when you consider how temperature affects solar panels' efficiency. The hotter it gets outside, the less efficient your panels operate, and their max voltage actually can decrease. In a parallel system where the voltage is the same as just one panel, it is possible that the max voltage will decrease so far that it's not producing enough volts to charge your battery. In series, because your voltage stacks, you have a better chance of avoiding that scenario. Also, because our panels are mounted to our van, if one panel's in the shade, we always have the option of just moving our van. Perks of having a house on wheels.
Now, in order for us to bring power from our panels into the van so that we can connect it to our full electrical system and whatnot, we had to add a few extensions to the cables coming out of the panels. And we did that using an MC4 connector kit. And the kit comes with a wire crimper, some spanners, and a bunch of male and female MC4 connectors. And for our setup, we used 10-gauge wire because our panel configuration is in series, and we based it off of a wiring diagram we purchased from Explorers.life. So we're gonna connect our solar cables. These MC4 connectors need to go on here. These are gonna be the wires that are gonna run into the van themselves. For this one, I have to put on a female connector, which requires this male barrel. So this goes on and then it goes inside this housing. So this sits on the wire like that. And I'm gonna squeeze it in a little bit, it helps, like this. Can you see that?
Yeah.
So that's our connection there. Then you're gonna take your housing, and it comes in 3 pieces. It goes like that. So you're gonna go 1, 2, and then click this in and seal them together. Now, if you can't do this by hand, you can use the tools they give you that slide in like this. It clicks, and then you have a nice solid connection. So that's that wire. Then we come over to our negative wire. One thing to point out is to make sure you put the male silver terminal within the female connector body and the female silver terminal within the male connector body. We accidentally put the female connector within the female body, which got stuck, and then we had to cut it and restart, so make sure you don't do that. So here's our positive connection, and it's wired through, and we can now suck these zip ties. We gotta make sure you have baby safe scissors. And they cut amazing.
You gotta use them the right way.
Thumb is in the thumb hole.
There you go.
We've got our connection here made, and we're running back. So we might have to add a few more zip ties, but it connects right here, like this. Nice and solid. And we got this connection here and this connection here. Good. We have our panels running in 1, 2, 3, 4. It's just 3. Now we should run the rest of these all the way to the back, I suppose.
Uh-huh.
We're gonna organize these and get it to the back. But with that, you can run your wires down into your van. You just need to pop a few more holes.
But before we could do that, we still had to get our new rack with our panels back up to the roof. Thankfully, all it took was a little brute strength.
Good.
Keep going. And some luck.
What's up? Easy.
Fear.
Coming over the AC.
And we were good to go.
Okay.
On the safety side, we do not recommend you doing what we did. We're assuming you can come up with a better way.
So now with our rack up and mounted, we were ready to pop some new holes in order to send our wires down into our system. We chose this spot because we know it's in the back there where we're gonna fish our wires through the framework. And I just centered it on these 2 ribs, and then I put my grommets down to see if they're evenly spaced, because those are gonna be protecting the wires from the metal. And I wanted to make sure they fit in there like that. So this is our entry gland. So it's like a waterproof entry port. I'm gonna seal that down with some butyl and then probably do some type of weather sealant, like a silicone around the edge of it. And in order to make those holes, we just used a step-up bit and drilled up to a size that was gonna fit these little grommets we bought so that our wires weren't gonna rub directly on exposed metal. And feeding your wires through the entry gland is pretty straightforward, but next you'll need to seal the entry gland to the surface of your van. First we tried using some butyl with some silicone and it didn't work out, and I'm not sure if it's because it was like kind of snowing out, really cold and wet. Then we decided we'd try to use some 3M double-sided sticky tape.
Would you like a ladder?
No, it's okay.
Okay, just don't fall.
Along with some Flex Seal spray. And the 3M tape works really well. Like that has water sealed it and kept the whole thing down. But that spray actually bubbled up. So we're now gonna have to go back and resort to our trusted Flex Seal paint on stuff. And you can always use lap sealant if you'd like. Now once your wires are running down into your van, you're gonna need to have them run to a breaker, and then from the breaker to your charge controller. And if you want to see a more in-depth installation process of those 2 items, you can refer back to our previous video. It's later in the video, but we put a little like chapter marker so you could skip right to it, and that'll walk you through everything we did when it comes to the breaker and charge controller.
But since we're wiring in series, we decided to go with the 150 Smart Solar Charge Controller from Victron. And the 150 just means it's capable of accepting 100 volts and 50 amps, which is more than enough for our system and leaves us room to grow if we decide in the future that we want to add another panel.
You're
Ew, stop drooling on me. You're not sweaty, you can sweat.
And that covers our system. We've been happy with the panels so far, and they've been charging our batteries without any issues. The only struggle we faced was with mounting when we added our own holes to mount it to our roof rack. But I think if you stick with the pre-drilled holes that come with the panel, you probably can avoid that issue entirely. And so now we've covered our full system, and we hope that it's helped. You know, this is a lot of content. It took a lot of work. I probably won't be doing this again, but we did learn a lot along the way, and I think we're definitely way more well-rounded than we were coming into it.
Super smart.
Semi-smart.
But thank you to our partners at BougeRV. We're excited to test this 9BB panel setup out because there's not a lot of other companies that are offering that design. So we'll see how it goes.
Yeah. And if you're new to the channel, please subscribe or
comment.
Yeah, tell us what we're doing wrong. We're open to all of that as
we
well.
love it when you're mean to us.
And if you've been here, just keep doing what you're doing. Thank you. We appreciate the continued support.
We do really appreciate everybody that's stuck on with us. Actually, I appreciate everyone who stuck after I came on and didn't abandon ship. I was afraid you wouldn't like me.
Yeah.
Okay. All right, come on.
You guys gotta say
Girls,
bye.
come here.
Girls.
Bye.
See you guys. Bam. My audio.
Your mic.
It's still recording.
Upside down superhero. I don't know how to do that without hitting my head. Whoa.
Today, we're talking about our solar panels. I couldn't have said that any worse.
How's that?
I think that actually worked pretty well. Now I'm just gonna pop my rope off and then put this back in our case and we'll head out.